Hi, and welcome back to my channel. If you're watching this live stream or you're watching back the video later, today I'm going to be going through Paper 1 Non-Calculator 2024. Sorry, put my cookies to one side. June 2024 Non-Calculator Further Maths paper. So we're going to do about half an hour to an hour of this, and then I'm going to carry on and finish the paper tomorrow. It's an hour and 45 minutes, so I will do as much as I can, as quick as I can, and see how much I can get through. But hopefully, anyone watching this finds it useful. Yes, right. Work out the value of t, where t divided by 20, and then we square root it. So, this is a non-calculator paper we've got to be aware of. Let me just get my pen set up. I'll switch this on, got everything else sorted, but not sort this bit. Right, non-calculator. So, okay. So we've got 2.42 times 10 to the power of 3. Well, that's going to be jump over the 4, jump over the 2. That's 2 jumps. So 2, 4, 2, 0. And so what we've got to do is we've got to do square root of 2, 4, 2, 0 over 20. And hopefully this is a nice square number when we divide by 20. So divide by 0, well, sorry, divide by 10, not divide by 0. You can't divide by 0, but divide by 10, that'll cancel those zeros. Divide by 2, we're going to get square root of 121 on both sides, which when we square root that, we are going to get 11. Okay. So that's that one done. The next one is factorise, and actually this one is a difference of two squares because we've got x squared and we've got y squared. So we're going to write this as x plus y in one bracket and x minus y in the other bracket. Okay. And that's the answer. That's literally it. X plus y, x minus y. Okay, next question. I haven't looked at any of these questions beforehand either. There is one topic which I haven't actually taught in a long time and haven't done it in a long time as well, which is vectors. So we'll see how much I can remember when we get to that question. That'll be interesting. Right. The nth term of a sequence is 3n plus 4 over n. Circle the limiting value of this as n goes to infinity. Now, what we can do is we can rewrite this like this. So 3n divided by n is 3, plus 4 divided by n is 4 over n. Now, if we, well, basically, as n gets larger and larger inside the 4 over n parts, just zoom in a little bit more, then what we're doing is we're dividing by a bigger and bigger number, and so this 4 over n is going to get smaller and smaller and smaller, and so the answer would be 3, because 4 over n would go to 0, the bigger the value of n is. So I've just divided each term here by the denominator. 3n divided by n is 3, 4 divided by n is 4 over n, and then because that's a reciprocal function and we've got the letter in the denominator, as that gets bigger, the 4 over n will go to 0. Right. The equations of two straight lines are y equals 3x equals y minus 3x equals 4 and 6y equals 18x minus 5. Show that they are parallel. Right, well, y minus 3x is equal to 4 if we add 3x to both sides of the equals. We are going to get y is equal to 3x plus 4, so our gradient there is 3. And if we look at the other line, 6y is equal to 18x minus 5. Divide everything by 6. So divide all the numbers by 6, we get y is equal to 3x minus 5 over 6. And then I'd write a statement. Therefore, 3 dots. As the lines have the same gradient of 3, they are parallel. Okay, next question. Question 5, we've got to differentiate. And before we differentiate, we want to write all of this as x with a power. So we're dividing here. So you're going to subtract your powers. And so we get y is equal to 4. And then we've got 3 take away 4. So x to the power minus 1. And then from there, we are going to do x to the power of 7 divided by x to the power of 4. So 7 take away 4 is 3. So plus x cubed. Okay, I'm going to rewrite that plus because that was a bit, well, very neat. Right, now to differentiate, we are going to bring this power down the front and multiplying by it. So we get minus 4x, and then we take 1 away from the power. So minus 2 plus, bring the 3 down, 3x squared, okay? And that's our answer there. We just need to put that on the answer line, but yeah, that's it. The main part with that one, and the bit that people would forget, is, well, basically writing it like this. Once you've got it written like this, the differentiation bit is fairly straightforward. Okay, so it's just writing it in index form, then getting rid of that denominator. Okay. Oh, clicked on the wrong thing. Scrolling down, we've got point A, we've got point B. They lie on a circle. AB is the diameter of the circle. Work out the equation of the circle. Now, if AB is a diameter, then the midpoint is going to be the center of the circle. So midpoint of AB is going to be, well, minus, basically add your coordinates together and half it. So minus 12, add 12 and half it. That's my x coordinate. And then 1, add minus 1 and half it. So that's going to give us, well, 0, 0, which is pretty nice. So then we know it's going to be x squared plus y squared. And then that has got to be equal to r squared. Now, there's a couple of ways we can do this. We can go from the center and we can work out the distance using the 2021 paper. Okay. What I will do, if there's any specific questions in that 2021 paper that you would like me to do, if you put them in the chat, and then on Wednesday night, I am going to do questions from any papers. So I'll go through any specific questions then. And then I may do the 2021 paper at another point in time, but I'm going to stick with going through one whole paper for today and tomorrow. And then Wednesday, it's like I say, it's going to be any questions. Is this just GCSE maths, not further maths? So further maths I'll be doing today, tomorrow, and Wednesday. Okay. But if you want me to do GCSE maths, let me know and I can try and schedule that in regularly at some point in time. Yeah, just let me know. The reason I'm doing the further maths is because students in my school have got a further maths exam on Thursday. So that's the reason why further maths specifically at the moment. But like I say, I'm happy to do other things as well at other points in time. Right, okay, you've got a mock tomorrow. Is that the GCSE maths? And if GCSE maths, which exam board? Edexcel, AQA? Let me know. And if you put questions and specific question numbers in the chat, I can always have a look at those questions and help explain any of those questions to you, if that would be helpful. Right, going back to this question. We know x squared plus y squared equals r squared because we know the center is 0. We could work out the Edexcel. Okay, like I said, put in the chat any paper or any question number, and I will go through them for you at the end. Okay. So x squared plus y squared equals r squared. We can either work out the distance from 0, 0 to either of these points, or what we can do is we can substitute either of these points in, and then that will equal r squared. So what I'm going to do is I'm actually going to substitute, let's go with A, that point in. So I'm going to get minus 12 squared plus 1 squared, and that has to be r squared. So minus 12 squared is 144. plus the 1 is going to be 1. That's r squared, so we get 145 equals r squared. So our final answer is x squared plus y squared is equal to 145. Okay, right. Going to move on to the next question. So a point P, x, y is transformed using the transformation represented by this. So 4 minus 2, 0, 3. The image of P is -8 and 7. Work out the values of x and y. Okay, so something has undergone this vector transformation and we end up with -8, 7. And so what we need to do is we need to have this matrix, not vector, matrix multiplied by something. So let's call that xy. Okay, and that has to be equal to -8 and 7. Okay, and so the way we do this is we're going to do, basically what you do is you take this bit and you multiply it by this. Okay, and that would give us -8. Then what you do is you take this bit, -2 and 3, and you multiply it by xy, and that's going to give us 7. Okay, so almost like where these two things overlap. So you see this one's at the bottom, and this one's vertical. So we're going vertical and at the bottom, which is this one. Okay, the 7. So that's kind of the way that it works if you haven't seen it before. So we're going to get 4x plus, 0y is equal to -8. And so we get 4x is equal to -8. So divide by 4 on both sides and x is equal to -2. Okay, let's replace that. Well, actually, we don't need to replace it yet, but we'll use that in a second. And then what we're going to do is we're going to do -2 times x. So -2x, 3 times y, because you kind of take this and you kind of turn it sideways. And so this -2 gets multiplied by the x, this 3 gets multiplied by y, and you add the two together. So -2x plus 3y is equal to 7. And then we've got the x is -2. So we're going to plug that in to what we've just worked out. So we get -2, lots of -2, plus 3y is equal to 7. So we get 4 plus 3y equals 7. Take away the 4 from both sides, we get 3y is 3. Divide by 3 on both sides and we get y is equal to 1. And there are our answers, okay? So y is 1, x is -2. Okay, right, moving on to the next one. We've got 5, solve by factorising. Well, the first thing to notice, this is a cubic, which further maths are super. Thanks for putting that question in the chat. I'll have a look at that shortly. I'm not going to like the look of it. I'm actually going to see if I can factorise the x out, which I can here. So x, and then it's going to need 2x squared minus 9x minus 5 is equal to 0. Now, I've got to remember this is a non-calculator paper, so we're going to have to explode or split the middle. And so 2 times -5 is -10. So I'm looking for factors of -10 that add to make -9. And I can work this one out. It's pretty straightforward. It's going to be -9 and, -10 and 1. Or 1 times -10. They will add to give -9. So we're going to get x, 2x squared, plus 1x, minus 10x minus 5 is equal to 0. I'm going to rewrite that x because it's not the best writing of the letter x. Now what we're going to do is we're going to factorise the 2x squared and the 1x, so that would just be x outside. I'm going to have 2 lots of brackets here, which is a little bit messy. So you might have wanted to do square brackets on the outside here, but it doesn't matter. It doesn't matter. Just got to be careful. So we'll take the x out of these first 2 terms. I'm trying to highlight them so you can see what I'm doing. We're factorising these 2 terms here. I'm going to use the other colour. Let's go green, and we'll factorise these 2 in a sec. So x, and then we got 2x plus 1. And then we're going to have -5 and then it's going to be 2x plus 1 again equals 0, and then we're going to get x. Factorise the 2x plus 1 out, so it's 2x plus 1, and then we're going to get x minus 5 in the last bracket, and that's equal to 0. Okay, so that's our answer. Okay. Now, it says solve, so we're not quite finished because we then need to get x is 0, or 2x plus 1 is 0, so we get x is minus a half, or we have that x is 5. Make sure with every question you'll check the wording at the end just to make sure there's no, they haven't finished or anything like that. Yeah, but there are answers there at the end. If it said factorise, then that previous line would have been it. But solve, we've got to get the solutions. We've got to get x equals. Okay, next one. We've got A, B, C, D, E, F, G, H is a cuboid. Work out the length of A to G, which is, and I'll do this with a straight line on here, going from A down to G here. Now that is directly above this line going from G to E. So we need to work out that length first of all, if we can. And we've got 3 there, so that would be 3. Now we're using Pythagoras. I know this is 5 because 3, 4, 5, and we've got this is 12. Okay, 3, 4, 5 is a Pythagorean triple, which is quite commonly known. And then we've got to do 5 squared, add 12 squared, and square root it. So this will be a Pythagorean triple as well, I'm pretty sure. I just can't remember. I think it's 13, but I want to double check. So 144 and 25 is square root of 169, which is 13. Done. So that was a pretty easy one, pretty straightforward at least. Okay, next one, what have we got? I'm just going to quickly see how many questions we've got actually on this. So we're on 10, which is quite quick compared to the GCSE questions I was doing, the IGCSE questions. This goes up to 22, 23, 23. So I'm going to get to 12, okay? So I've got 10, 11, 12, and then I will have a look at that question that's in the chat from another paper. Okay, so 10. Zoom this out slightly here. A function is given by f of x is minus a half x plus 21. And this is true from between 0 and 2. So this has got to be 2 here, there. And then we have ax squared plus bx between 2 and 6. Okay, now we can work out the height of p here by substituting 2 into this first bit. So if we do minus a half times 2, plus 21, we can get the y value. Now I'm looking at my calculator there. I don't need my calculator, and I'm not allowed to use it anyway. So a half of 2 is 1, so it'd be minus 1 plus 21, which is 20. Okay, so this would be a height of 20. Well, what that gives us is it gives us a coordinate, 220, that would work in this next bit for ax squared plus bx. Okay. Right, now the next bit is 6 and 12, and we know that's going to work as well. So what we're going to do is we're going to substitute in 6 and 12, and we'll get some amounts of a and b. So let's start doing that. So we have got a times by 6 squared plus b times 6, and that's got to be equal to the y value, which is 12. Okay. Then I'm going to do the same thing with the other point, which is 2 and 20. So we're going to have a times 2 squared plus b lots of 2 is equal to 20. Now let's simplify both of these. I'll scroll down now. So we're going to get 36a, let's call them 1 and 2. So equation 1 over here, we're going to get 12 is equal to 36a plus 6b, and then equation 2, we're going to get 20 is equal to 4a plus 2b. And then from there, we need to, well, this actually this one I can divide by 6 everywhere, and this one I can divide by 2 everywhere. So divide by 6 here, I'm going to get 2 equals 6a plus b. And divide this one by 2 everywhere, I am going to get 10 is equal to, what's just happened there? My tablet may run out of battery again. What happened in the other stream? Might have to plug this in. Let's see. 10 is equal to, divide by 2, we get 2a plus b. Right, well, actually, from this point, we can just subtract them. So if I call that 3, equation 3 now, to equation 4, if I do equation 3, subtract equation 4, then I'm going to get 2 take away 10, which is minus 8, is equal to 4a, and then the b's will cancel. So a is going to be equal to minus 2, okay? And then from there, if we plug that into one of the equations, I'm going to have to plug this, my tablet in, my drawing tablet. If we then plug that a in, we can, there's Alexa, thank you, Alexa. If we substitute a equals negative 2 into either of those equations, but number 4 is probably the best because the coefficients are smaller, we can work out the value of b. So we have got, scroll it down slightly, substitute into, I should have written, equation 4. We get 10 equals 2 lots of minus 2 plus b. So we get minus 4 plus b. And then add 4 to both sides, and we get b is equal to 14, and a is minus 2. Super. Okay, next one, 11a. 3x minus 7 is a factor of this. Work out the other 2 linear factors. So we're going to do, well, basically we need to either solve it or we need to factorize it, basically, is what we need to do. There's a couple of ways, and actually I can't remember which one you do at AQA further math. So I'm going to show you 2 methods to do this. Okay, I'm going to show you one that involves factor theorem, and I'm going to show you one which is called algebraic division. I'm pretty sure you do algebraic division anyway, so I'll go with that method. We'll go from there. So algebraic polynomial division at first seems really confusing, but it's just a case of practice, and it's very repetitive. It's the same thing every single time. So it's like long division, just with algebra. So divide this by 3x minus 7. You take your first term, 3x cubed, and divide that by the first term in our factor, so 3x. So 3 divided by 3 is 1. X cubed divided by x is x squared. Then we're going to minus the x squared times everything. Now that will cancel out the 3x cubed. It has to, because we just divided it by the first term. So we're going to get 3x cubed, and then x squared times minus 7 is minus 7x squared. Okay, I'm going to put a line underneath. 3x cubed subtract 3x cubed is 0. Minus 4 subtract negative 7, that's minus 4 add 7, so we're going to get 3x squared. We're then going to do 3x squared divided by the first term in our factor again. So 3x squared divided by 3x is x. And then we're going to bring this minus 13x down. And then we're going to subtract x times 3x, 3x squared. X times minus 7 is minus 7x. Okay, line underneath, we're going to subtract. 3x squared take away 3x squared is 0. And then we're going to do minus 13 take away negative 7. So that's minus 13 add 7 is going to be minus 6x. Minus 6x divided by 3x. So minus 6 divided by 3 is minus 2, and the x is going to disappear. Okay. Then we're going to bring this plus 14 down. And we're going to subtract minus 2 times 3x is minus 6x. Minus 2 times minus 7 is plus 14. And we're going to get an answer of 0 when we subtract all of this. That's what we want, because then we know it goes in exactly. Now from there, I then need to factorize this. Okay, x squared plus x minus 2. And hopefully you can work out the factors to that. So x squared plus x minus 2. We need numbers that multiply to give minus 2 and add to give 1. So it's going to be x plus 2, x minus 1. Okay, so x plus 2, x minus 1 are the other two linear factors. Now, the other way you could do this is by something called factor theorem. And essentially, the way you do that is by substituting values in to see which give you 0. Now, that's going to be more complicated, actually, thinking about this without a calculator. What you could do is you could try 1. So we could do, well, I know 1's an answer anyway. So if you get x minus 1, your solution is x equals 1. And we've got x minus 1 as a factor. So x equals 1 is our solution. So if we substituted that in, and the 3 lots of 1 cubed minus 4 lots of 1 squared minus 13 lots of 1 plus 14, if you work that through, you get 3 minus 4 is minus 1, minus 13 is minus 14, plus 14 is 0, therefore x minus 1 is a factor by factor theorem, is what you would say. Okay, now you would then do the same thing with minus 2, although again, that's going to be trickier with it being non-calculator. Not impossible, but trickier, and so you could do it that way. Obviously, with a calculator, it's quite quick. You can just substitute numbers in, see which give you 0, and then you can just reverse the sign and put it in a bracket. Okay. But yeah, that's probably the left-hand side. With it being non-calculator, it's probably the way they want you to do this here. You could do it also by inspections. That's another way of doing it. I'm just going to see what ways the mark scheme has. So you could use factor theorem. You could do inspection. You could do equating coefficients. Yeah, so there's various ways there. Yeah. The other way, inspection, just to say, is, well, if you know this, if I scroll up, you can see it actually. We know we've got 3x minus 7, and we know that has got to be times by something else. And 3x times x squared is 3x cubed. Okay, and minus 7 times by minus 2, which is the only way we can get a constant term, has to be plus 14. And then it's just about working out the middle. Now, zoom this in slightly here. Now, to get the middle, there's a couple of ways to get the x term. Now, you've got to think about how, basically, when you multiply this out, how are you going to get the x squared or the x term? You can pick either one, but let's go with x squared. To get x squared, we'd have minus 7 times x squared, okay? And that'll give us minus 7x squared. And to get from minus 7x squared to minus 4x squared, we need to add 3x squared. And so we need to do 3x times by x to get you the 3x squared. So that's basically how the inspection works. And if you looked at the other term, so if we looked at, and let's pretend we don't know it's plus x. If we looked at minus 13x, well, we've got minus 6x from 3x times by minus 2. We need another minus 7x to get minus 13x. So this would have to be times by x. And then you just factorize that second bracket, okay? So there's 3 ways really you can do that problem. Right, zoom out slightly more. Let's have a look at 11b. So x minus 2 is a factor of that. Work out the value of a. Now, this is, I would suggest doing this by factor theorem. If x minus 2 is a factor, then x equals 2 is a solution by factor theorem. And then what we're going to do is we're going to do, right, well, a times by 2 to the power of 4 minus 3a times by 2 cubed plus 5 lots of 2 minus 22 is equal to 0. 2 to the power of 4, 2, 4, 8, 16. So we've got 16a minus 2 cubed is 8 times 3 is 24a plus 10 minus 22 is equal to 0. So we got minus 8a, 10 take away 22 is minus 12, is equal to 0. Just check those numbers again. 16 take away 24 is minus 8. 10 take away 22 is minus 12. So minus 8a is equal to 12 divided by 8. And we're going to get a is equal to negative 12 over 8, which is the same as 3 over 2, or minus 1.5. Okay. So that's 11b there. Question 12. In triangle ABC, cos A is 3/4. Work out the length of BC. So here, we need to use the cosine rule, and that is a squared equals b squared plus c squared minus 2bc cos A, which is what we're told. So that's 3/4. That's going to be our A. B and C don't matter. So let's start substituting our values in. So a squared equals 12 squared plus 10 squared minus 2 times by 12 times 10 times by cos A, which we're told is 3/4. Remember, we need to work this through. So a squared is equal to 144 plus 100 minus 12. Well, let's actually do 3/4 of 12. 12 divided by 4 is 3. 3 times 3 is 9. 9 times 2 is 18. 18 times 10 is 180. So a squared is equal to 244 minus 180. So a squared is equal to 64. So A has to be positive, so A is equal to 8. Okay. So that's it. Now, again, don't get negative 8 because it's got to be a positive answer because it's a length. Right, I'm going to leave that here, and then I'm going to try, well, I will, do my best to finish off 13 up to 22 tomorrow. Just have a quick look through them, make sure there's nothing in there that I think is going to take a really long time. This is circle theorems. Okay, we got some angles and a ratio. Okay, this one. Okay, just got a yep. That shouldn't be too bad. Rationalizing the denominator. Stationary points of a curve. Here we've got a quadratic. What have we got to do? Straight line, work out approximate solutions. Indices. Always nice questions. Now this one, yeah, trig identities looks nice. Okay. Nth term of a quadratic sequence is this. First 4 terms of this, work out the values of x and y. Okay, quite nice, and then that's the end. Right, so not too bad of a horrible, not too much of a nasty paper, I don't think. I think that paper's quite nice, generally. Yeah, I don't like those 2 matrices questions in it, to be honest, but you know, that's by the by, really. That's just my preference for matrices. Okay, so what I'm going to do is I'm going to leave that there, and I am going to quickly have a look at question 18, 2021, November Edexcel, because that's been requested in the chat. So I'm just going to find that paper quickly, and then I will go through that. Okay, give me 1 second. So it is 2021 November Edexcel. Please. We got 2021. November 2021. Which paper is it? Ahmad. Which paper? Paper 1, 2, or 3? If you're still watching, that is. Hopefully you are. Well, if you let me know which paper it is in the chat, I will find it and I'll go through it. Paper 1, 2, or 3 is what I need to know. Right, I'm going to assume that one is not in the chat anymore. Now you do see this, Ahmad. Put a comment in the chat, so let me know which paper it's on. I'm more than happy to go through it and explain. Yeah. Okay, no worries. I'm going to leave the stream there then. Finish there. I'm going to finish eating my cookie and get some dinner, some real dinner. Right. Thank you very much for those that watched that, found that interesting, found that useful, even if you didn't watch it live, even if you watched it later. Hopefully that was useful and helpful. All right, I will see you tomorrow for another stream, similar time, maybe slightly later. Yeah, I'll try for 6:30 again, and yeah, we'll finish the paper off tomorrow. All right, till then, bye-bye.